Hello everyone, welcome to Study Zone. Today we are going to discuss about tautology, contradiction and contingency. So tautology are the statements where the compound propositions are always true. So here in tautology the first letter starts with T, right? So in tautology all the truth values are true. So here in tautology here the first letter starts with T, right? So all the truth values are true. And then contradiction. Contradictions are the propositional logics where all the truth values are false. So what about contingencies? Contingencies are the compound propositions where the truth values are the mixture of true and false. So here there is a mixture of true and false. If the truth value is only true, then it is tautology, and if the truth value is only false, then it is contradiction, and if the truth value is the combination of true and false, then it is contingency. So let us take examples so that you can understand it. So now for tautology. In tautology, let us take P. And I think all of you remember what is negation of P, right? So P, here this is the symbol to denote negation of P. And then P, here what is this symbol? This is OR, right? This is OR. So OR means plus. Here true, negation of true is false. And then false, negation of false is true. So let us take true as 1 and false as 0. So 1 plus 0 is 1 and 0 plus 1 is 1, right? So what does it mean? 1 means true and here also 1 means true. So here for both rows truth value is true. So for tautology the truth values are true. So this is the example for tautology. And then let us take an example for contradiction. Let us take same thing P, negation of P, P and not P. Here and means disjunction, which means multiplication. So true, false, false, true. 1 into 0 is 0, which means false. 0 into 1 is also 0, which means false. So here the truth values are both false, so it comes under contradiction. So we have seen the example of tautology and contradiction, and then we should see the example for contingency. So now let us see the example of contingency. For that, let us take P, Q and then P and Q. So and means multiplication, right? So true, 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 false, false, true, false, false. True into true is true, true into false is false, false into true is also false, and then false into false is false. So here there is a true and also false. So here if there is a mixture of true and false, then we can say that it is contingency. So if there will be a question like find out whether the truth table is tautology, contradiction or contingency. So on that time we have to find the truth values, and then according to the values you got, you have to get to the conclusion that whether it is tautology, contradiction or contingency. So we have seen the tautology, contradiction and contingency, right? So next, conditional statements. So in conditional statements there are 4 types: implication, converse, contrapositive and inverse. So in implication we have already seen it. Implication means P implies Q, and converse. Converse means you have to reverse it. That is Q implies P. It is converse. And then for contrapositive it is not Q implies not P. Okay, and then inverse. Inversing the contrapositive, that is not P implies not Q. Okay, so these are all the four types of conditional statements. They are implication, converse, contrapositive and inverse. Implication means P implies Q. For example, if it rains, if it rains, and then the ground will become wet, right? If it rains, then the ground will become wet. And then converse, if the ground is wet, then it means there is rain, correct? So if we reverse the implication, then it will become converse. And then if the ground is not wet, then we get to know that rain has not come. And then inverse, if the rain didn't come, the ground will not become wet. So this is about implication, converse, contrapositive and inverse. So here implication and contrapositive are same, and then converse and inverse are same. So let us take the truth table so that you will get to know that why implication and contrapositives are same and why converse and inverse are same. Okay. So now let us go through this truth table and then we get to know that how these things are equal. Okay. So true, 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 false, false, true, false, false. So then negation of P, false, for true, false, for false, true, for false, true. Here also same thing, for true, negation of true is false, negation of false is true, then false, then true. So I have told you before, right? For implication what we have to do? We have to fill the first row and last row first as true and true, and then P implies Q. So what we have to see? We have to see Q. So here there is false. So we have to fill F here. So here there is true. So what we have to fill? We have to fill true here. So don't get confused. And then Q implies P. So what we have to do? First we have to fill true, true, correct? Because here there is false, false, true and true. So and then what we have to do? We have to look at, now be clear, at last there is P. So what you have to do? You have to look at the column of P. So here there is true. So you have to write true. And here there is false. So you have to write false. And then not P implies not Q, right? So not P implies not Q. So same thing you have to do. Here there is false, false. So true, true, right? So here true, true, false, false. So true and true. And then what you have to see? Not P implies not Q. So look at the not Q column. False, sorry, true and then false. So true and then false. And then not Q implies not P, right? So you have to look at this column now. So same, fill the first row and last row, and then what you have to see? You have to see the not P column. So if there is false and then true, so write same like that, false and then true. And then now look which are all the columns have the same truth value. So here true, false, true, true. So here let's see the first column, P implies Q. So in P implies Q and Q implies P, true, true is equal. And then next look at second row, false, true. Is it equal? No, right? So implication and converse are not equal. So next look at next column, true, true. But here there is false, true. So they both are also not equal, implication and inverse. And then at the last column the values are equal. That's why implication and contrapositive are equal. As I told before, implication and contrapositive have same truth value, so they are equal. And then I have told you that converse and inverse are equal. So we can see here also true, here also true, here also true, here also true, here there is false and then false, here true and then true. So from this we get to know that implication and contrapositive are similar and converse and inverse are similar. This is about conditional statements. So this is the homework question under conditional statement, that is in P, student studies hard, and in Q then passes the exam. So for this write the truth values for P implies Q, Q implies P, not P implies not Q, and then not Q implies not P, and check whether the rows which I have told before are equal or not. And if you have any doubt, please ask question in comment section, then I will solve the question. So the next topic is precedence of operators. So it helps to understand which operator to evaluate first. So if you have a compound proposition like not P implies P or Q, like this. So with the help of these precedence of operators, we can evaluate the compound proposition easily. So the first preference is for the operator not. So precedence 1 for not operator, and then and operator, it has the precedence 2, and then the or operator, it has the precedence of 3, and then implication have the precedence of 4, and then biconditional have the precedence of 5. So let us go through few examples. So the first example is, first there is bracket, P implies not P and not P implies not Q. So we have to remember that when there is a bracket, we have to evaluate first the things which are inside the bracket, and then we have to evaluate the outer things, okay, and then the precedence of operator come. So if there is bracket, then we have to evaluate it first. So for this we have to write the truth table, and then we have to find whether the final truth value is tautology, contradiction or contrapositive. So let us solve this. So what you have to write, first thing P, and then Q, and then not P, and then not Q, correct? And then which is inside bracket, we have to evaluate this first, right? So not P and not P, and then P, we have to evaluate the outer bracket item. So P implies not P and not P. So P implies not P and not P. And then what we have to evaluate? Whole this thing. So for our convenience, let us take this as R and let us take this as S. So at last what will happen? S implies not Q. Okay, so first we will write the true and false values. True, 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 false, false, true, and then false, false. So not P, not Q. For true, false, false, true, true, and then not Q. So we have to write the negation of Q. True, false, true, correct, and then not P and not P. So we have to just check this thing. False into false. What will happen? False. False into false. False. True into true. True. True into true. True. Correct. And then this will become, so this, take this as R and then S. What's that? P implies not P and not P. So here we can't write the first element as true and the last element as true, because here both the values are not same. So we have to check this. Correct. Here true implies false. So we have to write false, and then true implies false. So false, and then false implies true. So this one, true and then false implies true, which means true. And then what we have to do? We have to do S implies not P. Correct. So what we have to do? First we have to check whether two values are same. Here false and then false. So what we have to write? We have to write true and then false and then here true. What we have to write? Here S implies not Q. Correct. So S implies not Q means we have to write this value, that is true, and then true false. What we have to write? False, and then true true, that is true. Here there is a mixture of both true and false values, so it will become tautology, contrapositive, contingency. What will it become? It will become contingency, because it has the both true and false values. So this is how we will simplify. First we will simplify the things which are inside the bracket, and then we will solve the things which are outside the bracket. Okay. So let us go through the second example. So what we have to do? Here we have to solve the first this thing which is inside the bracket, and then these values that is inside the bracket, and then we have to solve the AND operator. So let us take true, 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 false, false, true, false, false. So you all know that negation of true is false and negation of false is true. So I wrote the negation of P and Q, and then what we have to solve first? We have to solve P or not Q. So P, here it is, not Q, here it is. So or means plus, right? So true, false, true, that is 1 plus 0, 1, 1 means true, 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 false, 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 and then false, true, true. Done. And then not P or Q. So false, true, true, false, 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 and then true, 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 and then false, true, true, which means 0 plus 1. What will happen? 1. 1 means true. And then take this as R and this as S for simplicity. So what will happen? True, and here there is and, which means multiplication. 1 into 1, what is it? 1, and then 1 into 0, 0, 0 into 1, 0, 1 into 1, 1. So here there is a mixture of both true and false. Then what it is? It is contingency. Got it? So this is how you solve the precedence. With the help of precedence of operators, how we are going to solve the compound propositions. So let us take one homework question, solve it, and if you have any doubt, please do comment in the comment section.